Cosmic guest from the beginning of time. When an automated telescope system in Chile detected an unusual object moving in space on the first day of July, astronomers had no idea they were witnessing an extraordinary event. This was not a typical asteroid. What they discovered was a massive frozen water mass, older even than our planet, hurtling toward us from the depths of space at astonishing speeds. An unexpected event. The detection occurred during a routine sky surveillance. As the Atlas system was doing its usual job of scanning for potentially dangerous space rocks, its cameras caught something strange. Among hundreds of thousands of star images, a faint dot was moving at an extraordinarily fast pace across the sky. Within hours, observatories worldwide mobilized to confirm what seemed impossible. This object was racing at more than 60 kilometers per second relative to our sun. This meant it was fast enough to circle our entire planet in about 11 minutes. Such speed doesn't happen by chance in our solar neighborhood. When something moves this fast, it means only one thing. It has come from somewhere very different. Telescopes on multiple continents joined the chase. The ZTF in California searched through its archives and found it there too. Observatories in Hawaii captured its dim glow. Each observation strengthened what scientists were beginning to suspect but dared not believe.
It couldn't be from around here. The mathematical calculations told a clear result. This wanderer was following what astronomers call a hyperbolic orbit, meaning it would never return around our sun. Instead, it was just passing through, like a tourist on a cosmic journey, here briefly before continuing into the infinite darkness beyond. After the Minor Planet Center confirmed the findings on July 2nd, humanity had its third confirmed visitor from beyond our solar system. They named it C/2025 G3ATLS and marked it as the third interstellar wanderer we have ever confirmed. Just think, throughout all recorded history, there are only 3 objects we have confirmed definitely came from other star systems. It was almost completely missed. Here's the astonishing part. This cosmic messenger was almost completely slipping past us. An amateur astronomer named Sam Dean noticed something shocking while searching through telescope archives. Images of this object dated back to mid-June and had been sitting unnoticed in databases for weeks. It had been photographed more than 20 times before anyone connected the dots. Why the delay? The object was passing directly in front of the galactic core, where millions of stars create an incredibly crowded background. Finding it there was like noticing a single firefly in a stadium full of holiday lights. The dense star field provided perfect camouflage. Time was critical. Unlike asteroids that wander around for millions of years, interstellar wanderers are cosmic sprinters. They burst forth at incredible speeds, remaining visible for only a few months before disappearing forever. Miss your window, and that's it.
A giant among visitors. Analysis of archived images revealed something unexpected. This visitor was approximately 7 miles wide. To put this in perspective, imagine Manhattan carved from ancient ice and stone, then hurled among the stars for billions of years. Previous interstellar objects were cosmic pebbles by comparison. Size is extremely important. Larger objects retain heat longer, storing volatile materials in frozen storage for ages. This 7-mile-wide wanderer could theoretically preserve chemistry from its birth system in an almost unchanged state, like a natural time capsule. Even more interesting, the object was already active while incredibly far from our sun. A ghostly gas and dust cloud surrounded it, far beyond Jupiter's orbit. Most comets from our own system remain dormant until they get much closer. This suggested the presence of extremely volatile compounds that sublimate at extremely low temperatures. Moving at extraordinary speeds. This ancient visitor was racing at 130,000 miles per hour and was still accelerating. To grasp how absurdly fast this is, imagine a bullet passing from New York to Los Angeles in less than 90 seconds. That's the speed we're talking about. what could launch a 7-mile piece of ice to such incredible speeds? The answer lies in cosmic violence. When this object was part of another star system billions of years ago, something catastrophic happened. Perhaps two stars passed unusually close, their combined gravitational fields acting like a cosmic slingshot. Or perhaps a massive planet's migration disturbed the outer system and hurled countless comets into the void. When this visitor reached its closest solar approach in late October, it would be screaming through space at more than 200,000 miles per hour. An ancient wanderer. Oxford University astronomer Matthew Hopkins performed calculations that yielded incredible results. Using computer simulations to trace this object's path backward through galactic history, his team discovered something remarkable. This visitor likely formed when our universe was less than half its current age. Think about this timeline. When this comet first solidified from dust and gas around an ancient star, Earth did not exist. Our sun was merely a cloud of hydrogen floating in space, yet this object was already fully formed and beginning a journey through the cosmos that would last billions of years. The age calculation came from analyzing the object's steep orbit through our galaxy. Unlike previous interstellar visitors that traveled roughly parallel to the galactic plane, this one approached from a sharp angle, suggesting origins in the thick disk of the Milky Way, a region containing the galaxy's oldest stars. Stars in that region typically formed 7 to 10 billion years ago, making them elderly citizens compared to our 4.6 billion-year-old sun. This visitor represents a frozen chemistry sample from when our galaxy was still young. From the galactic depths. This wanderer came from regions our species has never examined up close. While previous interstellar visitors traveled mostly parallel to the main galactic disk, this comet cut through multiple galactic layers, moving from the ancient, thick disk toward our local neighborhood. Imagine our galaxy as a massive cosmic sandwich. The thin disk, where we live, contains young, metal-rich stars like our sun. Above and below lies the thick disk, inhabited by ancient stellar citizens that formed when the universe contained far fewer heavy elements. The steep orbit shows this object has been wandering for an incredibly long time. It may have spent billions of years in cosmic rural areas, rarely approaching another star system. This makes any material it carries especially valuable, pristine samples from the early galaxy. Water from another world. Spectroscopic observations revealed clear evidence of water ice sublimating directly from solid to vapor. But this was not ordinary water. These molecules had condensed around another star when the universe was half its current age. These water molecules formed in an alien planetary system billions of years ago, then spent ages frozen at temperatures just above absolute zero. Now, as our sun's warmth reached this cosmic ice cube, we were getting our first glimpse of alien chemistry. Initial estimates suggested the comet was releasing between 0.3 and 4.2 kilograms of material every second. This is like a cosmic water sprinkler operating at Manhattan scale, releasing ancient water locked away before our solar system existed. Infrared observations also revealed something unexpected: silicate grains approximately 10 micrometers in radius, mixed throughout the water ice. These tiny particles represented dust from the original disk where this comet formed, microscopic remnants carrying information about an alien star system's chemical composition. Racing against time. The observation window was closing rapidly. Unlike comets from our own system that can be studied for years, interstellar objects race at incredible speeds. This visitor would remain visible until September, be hidden behind our sun from October through November, then briefly reappear in December before permanently fading.
The most frustrating aspect? The comet would reach its closest solar approach in October, precisely when it would be hidden from Earth. This is typically when comets display their most spectacular activity. We would miss the entire show. Observatory schedules worldwide were rewritten in real time. Hubble cleared its calendar. James Webb prepared multiple viewing sessions. Ground-based telescopes began intensive monitoring campaigns. Even amateur astronomers joined the effort, using small telescopes to provide continuous coverage. Overshadowing previous visitors. When Oumuamua first appeared in 2017, it revolutionized our understanding of interstellar objects. This cigar-shaped visitor was roughly 400 meters long. 2 years later, Borisov arrived as a more traditional comet, approximately half a mile wide. This new arrival made both seem almost humble. The difference was like comparing a city bus to an aircraft carrier. While Oumuamua could fit inside a large stadium, this object would cover an entire downtown area. The mass difference was even more dramatic. While Oumuamua weighed roughly 30 million tons, this visitor contained at least 1,000 times more material. This is comparing a large building to an entire mountain. A one-way journey. Orbital calculations revealed something that sent shivers down astronomers' spines, an eccentricity of 6.22. In celestial mechanics, any value greater than 1 means hyperbolic orbit, moving too fast to be captured by our sun's gravity. This visitor exceeded that threshold by more than 6 times. The longest comet orbits in our solar system have eccentricities just below 1. Halley's Comet measures 0.967. Even previous interstellar visitors were modest by comparison. This arrival was in a league of its own. There would be no return visits, no second chance, no opportunity for follow-up studies in the future. This was a one-time cosmic performance.
Coming to life. 4 astronomical units from our sun, this ancient ice ball began to awaken. While still beyond Jupiter, it began developing a faint gas and dust cloud. This was extraordinary behavior. Most comets remain dormant until they get much closer. The early activity suggested extremely volatile compounds that sublimate at remarkably low temperatures. Spectroscopic observations began revealing the chemical composition of this ancient breathing process, showing undeniable signs of water vapor and silicate dust. The awakening promised to intensify dramatically as the object continued inward, with solar energy potentially triggering spectacular outgassing events. Global scientific mobilization. The discovery triggered unprecedented international cooperation. From Chile to Hawaii, observatories immediately began sharing data, coordinating schedules, and pooling resources. It was like a cosmic emergency response. In Chile's Atacama Desert, the European Southern Observatory deployed its entire arsenal of instruments. Hawaii's twin Keck telescopes joined forces with Subaru and other facilities. Each night, these giants would pass the observational baton as Earth's rotation carried them into daylight. Real-time data sharing became standard. Observations made at one facility would immediately be transmitted to analysis teams worldwide, allowing rapid follow-up observations elsewhere. Graduate students found themselves working alongside Nobel laureates, united by shared excitement. Space telescopes joined the hunt. On July 21st, Hubble captured its first images, adding its legendary precision to the investigation. Space-based observations provided something ground telescopes couldn't: completely unobstructed views above Earth's turbulent atmosphere. Hubble's cameras revealed subtle features in the dust distribution, suggesting material was being ejected preferentially from specific regions. These patterns revealed information about rotation and internal structure. But the most powerful infrared telescope ever built was preparing something even more ambitious: Webb's infrared vision. The James Webb Space Telescope represented humanity's ultimate tool for studying this visitor. While optical telescopes captured beautiful images, Webb's infrared vision could penetrate dust clouds and detect molecules completely invisible to human eyes. Webb's observation plan included crucial sessions in August before the comet disappeared and in December during its reappearance. This would allow comparison before and after closest solar approach, revealing how billions of years of accumulated ice responded to intense heating. Webb's unprecedented sensitivity could detect compounds never before observed in interstellar objects: water vapor, carbon dioxide, carbon monoxide, methane, complex organics, each with its own unique infrared signature. Should we chase it? The discovery immediately triggered discussions about launching spacecraft to intercept this visitor. Several robotic explorers were potentially positioned for encounters, although each would require significant modifications. The European Space Agency's JUICE mission, currently en route to Jupiter, emerged as one promising candidate. NASA's Psyche mission represented another possibility. Both could provide unprecedented close-up observations, though neither was designed for comet studies. More ambitious proposals included dedicated interception missions launched specifically to reach this target. Small, lightweight spacecraft could reach the necessary speeds using existing technology. The alien technology question. Harvard astrophysicist Avi Loeb asked a controversial question: what if this isn't natural? His paper suggested this interstellar visitor might be alien technology disguised as a comet. The scientific community reacted with everything from cautious interest to outright dismissal. Loeb's arguments focused on unusual characteristics, like the beneficial orbit and suspicious timing. However, overwhelming evidence supported natural origins. Every spectroscopic measurement showed normal comet behavior. Water ice, silicate dust, and other compounds matched expectations for ancient comets formed around other stars. The object's coma development, tail formation, and outgassing patterns followed well-understood physics. Confirmed natural origins. Every scientific indicator confirmed this was genuine ancient ice from another star system. The spectroscopic fingerprints told a clear story of natural formation. Water ice signatures appeared at exactly predicted wavelengths, with no unusual features suggesting artificial construction. The chemical composition provided the strongest evidence. Ground telescopes detected the same molecular species found in countless other comets. These compounds form naturally in cold, outer planetary regions, exactly where this ancient comet formed. Thermal modeling revealed heat conduction properties consistent with natural ice-rock mixtures. Surface temperature variations followed expected patterns for rotating bodies with heterogeneous composition. Galactic archaeology. Studying this visitor was like conducting archaeology on a galactic scale. Every spectroscopic measurement revealed information about stellar formation processes occurring when the Milky Way was half its current age. The thick disk origin suggested formation around a metal-poor star, one of the galaxy's early generations. These ancient systems formed from primordial materials not enriched by multiple stellar explosions. The resulting comets contained higher hydrogen and helium compound ratios, with less rocky material. The water ice detection was particularly significant. This H2O evaporated when the universe contained roughly half its current inventory of heavy elements. Analyzing isotope ratios could reveal information about nucleosynthesis processes in early stellar generations. Transforming future searches. This discovery was transforming how we search for interstellar wanderers. The successful detection proved such objects are far more common than previously believed. If we found 3 within 8 years, thousands or tens of thousands must be passing through undetected. The discovery highlighted critical gaps in cosmic surveillance. This massive 7-mile comet was almost slipping away despite being one of the largest we're likely to encounter. Smaller visitors carrying equally valuable scientific information are certainly passing by regularly.
The Vera Rubin Observatory is about to revolutionize interstellar object discovery, potentially finding dozens annually. This revolutionary telescope is designed specifically for wide-field, high-cadence scanning that makes detection possible. Its massive camera will photograph the entire visible sky every few nights, creating a comprehensive movie of cosmic motion. Computer simulations predict Rubin could detect between 5 and 50 interstellar objects per year, transforming rare discoveries into routine research.
The long goodbye. Following its close approach in October, this cosmic messenger will begin climbing out of our sun's gravitational well. The hyperbolic orbit means it possesses more than sufficient speed to escape permanently. When it crosses Neptune's orbit in 2027, it will still be traveling at approximately 40 kilometers per second relative to our sun. The exit point will occur somewhere at the heliopause, roughly 100 astronomical units away, where our sun's influence yields to interstellar space. The journey to the nearest stars will take hundreds of thousands of years. During this incomprehensible voyage, it will return to the deep cold of space, where any remaining volatile compounds will solidify again. Unanswered questions. Despite months of intensive observation, fundamental mysteries remain unsolved. The exact star system where this ancient wanderer formed is unknown. Somewhere among hundreds of billions of stars, an ancient sun warmed this comet as it formed. The internal structure remained largely mysterious. Did this 7-mile core contain pristine materials from original formation? Or did billions of years of cosmic radiation and micrometeorite impacts alter its composition? The presence of complex organic molecules remained unconfirmed. If this ancient comet contains carbon-based compounds formed around another star, it would provide crucial insights about the prevalence of organic chemistry throughout the galaxy. A lasting legacy. This visitor demonstrated that our galaxy contains countless time capsules from its ancient past, floating through space and occasionally offering brief glimpses into cosmic history. Humanity's first detailed study of such an ancient object marked a turning point in understanding the universe's deep history. We are no longer limited to studying our own solar system's 4.5 billion-year timeline. The cosmos has delivered a sample from its youth, reminding us we are part of a much larger and older story. The questions this visitor carries back to interstellar space will inspire future generations to build better telescopes, launch more ambitious missions, and continue humanity's eternal quest to understand our place in the cosmic order. We're also curious about what kind of inspiration it will give you. Let's discuss in the comments. Thank you for listening to me. See you in the next video. Good night.